All right, well, welcome to our spring 2022 Ionic Viper nanoCHAT YouTube seminar series. So this semester, the theme of our weekly series is the nanoCHAT NeWBiEs. So we're going to be capturing what it's like to teach inorganic for the very first time in real time. So we'll be hearing from two Ionic members from the U.S. Naval Academy Chemistry Department. So we have with us Wes and Shirley Lynn. So tell me, this is your last full week of classes, and so what's going on? Do we have exams coming up? What's the end? How are we wrapping this all up?
Yeah, it's a great question. It feels like there's still so much more that we could be doing, but we are wrapping up. We finished our last formal chapter, which was on ligand substitution. And I was just, as Wes mentioned, in an earlier episode of NeWBiEs, just excited to get to reactions again. And then doing the mechanistic work, I just really, really like that. And I used to teach organic in the major, trying to make those connections between SN1, SN2, to what they see in ligand substitution with the associative interchange. I've made a big point of that, especially because these majors are the ones that had organic during the pandemic. And so they had a strange learning experience, right? So getting to revisit that was really, really nice. And I just really love mechanisms and could talk about them all the time.
Yeah, I agree. I really enjoy mechanisms. And I think that they can sense that I'm very excited about ligand substitution chemistry. I feel like this is a really nice way to end the semester. I think it kind of ties together everything we've been doing, and in some ways kind of ties the entire major together. This is the last course they're taking in the major, so we can make a lot of references back to organic. We can make references back to the beginning of the semester with MO theory, crystal field theory, hard salt acid base theory, and it kind of all comes together to understand how these reactions happen. So I think it's been a lot of fun. I think they've really enjoyed it too. So I think it's been a great way to finish things up. And now I'm actually going and writing the third exam, and that's also a ton of fun because now I'm able to dig into the literature a little bit and include examples from primary literature on the exam. So as I'm writing a question, I'm actually going to put a reference in the question so that they see, this is coming from some paper, not just like coming out of a textbook or some test bank somewhere. Like this is something that's happening in the field right now. So it's been a lot of fun. I'm actually kind of sad to see it end. As much as I'm ready for the semester to end in some ways, I'm excited. I'm not excited to see this material end.
So I have a question about that, Wes. So when you write your exams, do you take a lot of exam questions from Viper? I know that for me, when I do, that's my go-to when I'm trying to find a new question, something that they haven't seen before.
So normally Shirley and I have been co-writing them. And I think she's mined Viper a little bit more than I have, whereas I've kind of just gone back to some older materials that I used when I took this class an undisclosed amount of time ago. But now I'm doing it all by myself because we've split up the work a little bit. And I've gone through and tried to find some, but for a lot of these, I've actually just kind of dug into SciFinder because I'm just trying to find some primary literature examples. But now that I think about it, I'm sure I could have found that on Viper too, but for some reason, I just didn't go there as my first stop this time.
Well, I would say if you are finding some good questions that you're writing from primary literature, I go ahead and submit an LO to Viper. We definitely need all of the content and material that we can get. So
I agree. And I've noticed that our coverage of certain topics is very uneven, right? Like we have a lot of questions in a certain area and then very few in another area. So just trying to even that out a little bit more would be great, especially because we have different types of LOs. And the problems that LOs are the ones that we usually use for our exam questions, right? So.
All right, so now that you're wrapping up and you have your last week here, and you're not able to get to really those advanced topics that that I know you all want to get to. So how have you found ways to incorporate things like bioinorganic, organometallic, maybe even some nanochemistry into your curriculum as you go through?
It is a challenge, and you feel guilty because you realize there's all this great material out there, and it's just, you can't take everyone through it all. So so this is something Wes and I had planned from the very start of the semester, is that we would end with a couple weeks of a group project. So we've put the students in groups of 2 and 3, and we've selected some literature articles that that they're going to work on, and they're actually going to model what we've been doing for them all semester long. We've been doing one literature discussion roughly per chapter, and now they get assigned their own literature article, and they get to write the questions. And so we're asking them to write a mini LO, if you will, on that article. And it's a stretch for sure, but we're there to help them. And we group the categories for the project such that there would be articles on bioinorganic and on materials, including nanomaterials, and then also on catalysis. So very, very broad categories. And within that, pick some literature articles that we thought would be good topics for them, and try to have them go back to what we learned over the semester and find those nuggets, like the same thing that we do when we're writing these literature discussion LOs. And I think it's going to be a lot of fun. And Wes has already collected some from his group, and I think they've looked good.
Yeah, I've collected just one so far, but it was on a challenging nickel, was it a nickel thioate compound, has biochemical applications. And there's a lot of really good stuff in there. And I was like, I hope they hit on all of these major themes. There's spectroscopy, there's CV, there's some distortions from what you would expect the geometry to be based on the electronic structure. And the questions that the students wrote hit on all of those things, to the point where I found myself giving feedback, because they're going to turn in iterations of this thing. There's going to be 3 drafts total. And every comment started with, this is a great question to ask, or like, this is a great point, or good find. So I'm hopeful that the rest of them follow suit. It's been a really, I think it's a fun project for them. And the nice thing too is that, so for instance, this group is digging into something biochemistry related, it's like bioinorganic, but they're also going to get the chance to share these with other groups. So, this group that's working on something bioinorganic may get to then complete the literature discussion for extra credit from someone who's working on, say, nanomaterials or catalysis. So in this way, they're kind of going to share and teach each other this material. And then we'll just kind of sit back and kind of guide them along the way. But this also brings up something interesting. I mentioned to my students the other day, they were talking about something, and for some reason it came up. I said, this used to be a 2-semester course, but we've limited it down just to the 1 semester now. I think they're just talking about how much material is in the course. And I was not expecting this. They were all like, oh, it should be 2 semesters again. Like, I was not expecting that take, that they seem to want more inorganic. So I don't know what that says about them or us, but I think that it kind of just speaks to that there's a lot of material here. And I think maybe that we're ending on this reaction chemistry. They're starting to get more and more excited about it. But in that way, I think this is a nice way to end the semester, that they can dig into this literature and kind of see and teach themselves some of this material.
That's fascinating. I did not know your students had said that. And yeah, it's been over 20 years since we've had a curriculum that included 2 full semesters of inorganic. So
they do a lot of things that surprise me, but that was the most surprising thing I think they've done all year.
Yeah. So at your institution, Kari, do you do like a foundation level course and then an advanced course, and what portion of students take each?
So we don't have a foundations course, but what we do have in the chemistry major is an intro to solid state course that they take in their sophomore year. So they take it kind of alongside organic. And then we also have an introduction to medicinal biochemistry for the students on the life sciences side that want to get into the major. So it's sort of like a way to get them associated with the major rather than just going through the sequence. So that's really nice. So, but then our advanced inorganic is junior, senior level inorganic. So they don't have that foundation, which I would love to have, but. All right, so it looks like we're coming to the end of our edition of NeWBiEs. So I want to thank you all. Thank you, Wes and Shirley, for the conversation, and to all who watched this video. So please feel free to comment about the nanoCHAT NeWBiEs in the Ionic Discord, in the Viper Pit, and join us next week, and we're going to hear all about these literature discussions that you guys have been talking about. So excited to hear about that. And thank you, everybody.
Thanks, Kari.
Thanks, Kari.
Bye-bye.
Bye.